10.2 arithmetic sequences in series. Let's go to this worksheet. So you've noticed I have formulas here. I will always give them to you. You'll always be provided them. Just gonna know how to use them. So find indicated, number one, find the indicated term of each arithmetic sequence. So it's an arithmetic sequence. We're using arithmetic sequence formulas. Remember the top one here is to use if you want to find a term of the sequence, hence term. If you're looking for a sum, we'll use the bottom equation. Either of the two. There's actually two here. There's this one, which I kind of like a little better, and then there's this one, which is a little easier if you have everything that you need. Anyway, to the first one. Find the indicated term. So I want to find the term. So a1 equals negative 18, d equals 12, and n equals 16. So let's write the formula first. An equals, I guess over there they have u's, but it's all the same. I'll put an. N equal a1 plus n times n minus 1 times d. Okay, and I have a1 is negative 18. I have d is 12. I have n is 16. So what I'm finding here is a 16th term. That's my n. So a16, just simplify this. Negative 18 plus 15 n minus 1 times 12. You simplify that and you get your answer, which is 162. So that's what the 16th term is. The first term is negative 18. We're adding 16 every single time. Sorry, we're adding 12 every single time. And we get 162. Next one, they want us to find the 10th term for this. So again, I'm just going to write down the formula real quick. An equals a1 plus n minus 1 times d. And in this case, they tell me, I know what a1 is. I can find it. a1 is just negative 1. The common difference is just, what are they adding every single time? If you look at it, they're adding 2 every single time. Right? Negative 1 plus 2 is 1. 1 plus 2 is 3. So my common difference is 2. What's my n? Well, I want a10. So if I plug 10 here, I'm going to plug 10 in there. Now remember, this is just like letting you know what term you're finding. So this is just a10 is negative 1 plus 10 minus 1 is 9 times 2. So that's 18 minus 1, so it's 17. So the 10th term, a10, is 17. So I went negative 1, 1, 3, 5, all the way up to 17. Same idea here, they want us to find a15. So write down the formula. I know what the first term is. There it is, negative 5. Common difference, you could find it. In this case, it's going down. They're subtracting 7 each time. And I'm looking for the 15th term. So a15 would equal, plug in 15. So a15 is negative 5 plus 15 minus 1 is 14 times negative 7. So that's 28. Negative 98 plus negative 5. So a15 equals negative 103. So that's the 15th term. Next one, write the equation for the mth term of a geometric sequence. So when they say the mth term, that means that they just want the equation. They want, like this guy. Well, that's not the best example. They just want the equation. They don't want an actual value. So mth term just means write the equation. So I'm going to write the equation first. a1 plus n minus 1 times d. So a1's the first term is 24. And the common difference is, what are they adding every single time? Looks like 11. Yeah, 11. 25 plus 7 is 35. 24 plus 7 is 35. 35 plus 7 is 46. And that's pretty much it. I just got to simplify it now, but that is the equation. It makes it a little nicer if I simplify it. So I get 24 plus 11n minus 11. Add up like terms. 11n plus 13. And that's the equation. So now if I want to find like the 10th term, I just plug in 10. 5th term, plug in 5. So that's the term, that's the equation for all formulas. Next one, same idea. So an equals a1 plus n minus 1 times d. The first term is 31. And the common difference, it looks like we're going down 14. The key thing is always the same. So like that, I don't want to subtract 31 minus 17, but 17 minus 3 was a lot easier. Down 14. So that's my common difference. So now you just plug it in. Distribute. So then you get negative 14n plus 45. Like that. Next two, a little bit tougher. So let me write them the generic form we gotta find. an equals a1 plus n minus 1 times d. So why is this hard? Well, we gotta find two things. We gotta find a1 and d. I have the common difference, d. I don't have a1 though. I have a7. So how do I find a1? Well, you plug in what you have into this equation. Anytime you're missing something, you go back to this equation and plug in what you have. So what do I have here? This tells me when I plug in 7, the 7th term is 21. That's what that means. A7, that's what this would be, is 21. So when you plug in 7, you get 21. That's all this thing means. Plug in 7, get to 21. Now look what happens if I rewrite it. 21 equals a1 plus 7 minus 1 is 6 times 5. So I get 21 equals a1 plus 30. a1 equals negative 9. So now I have a1. I can go back and write the equation. Right, the equation is an equals a1 plus n minus 1 times d. a1 is negative 9 and d is 5. I can simplify it like before. So an equals 5n minus 14. Right, so you have to do an extra step. Anytime you're missing something, you gotta do an extra step. You gotta find that a1 or find the common difference. So there we go. Next one, same idea, same issue. Right, so an equals a1 plus n minus 1 times d. I have d, common difference. I don't have a1. I do know though, when I plug in 9, it gets me 45. So when I plug in 9 for my n, I'm going to get 45 for my value, for my term. So we're going to use that to find a1. So now I know 45 equals a1 plus 8, 9 minus 1 times negative 3. So 45 equals a1 plus negative 24. Add 24 to both sides. 69 equals 81. And then plug it back into the equation. So my equation was this. And now we're going to plug in our values. We can simplify it to make it nicer. We get negative 3n plus 72. And there we go. Alright, so it's always the same thing. Look at what you have. If you're missing a1, go back, plug in what you do have. So I plug in 9 equals 45. Simplify all the way down, get your answer. Next one, application problem. Jose averaged 123 total pins per game in the bowling league this season. He is taking bowling lessons and hopes to bring his average up by 8 pins each new season. Find equations to represent the nth term of the sequence. So, for A, our equation is an plus, an equals a1 plus n minus 1 times d. What do we have? Well, he's averaging 123 games, 123 total pins per game. So let's say that's our first one, right? We're going 123. He wants it increased by 8. That'll be our common difference. Right, so we start 123 and we're going to add 8 each time. So what's our equation? Well, simplify this. Distribute an equals 8n plus 115. So that's our equation. If the pattern continues during what season will Jose average 187 per game? So now they're saying, in what season we average 187? So where did I plug that 187? Is it for n or for an? Well, n is the season. Like the points per game is the term number. So I'm going to plug in 187 over here. We're going to solve. So for B, we 187 equals 8n plus 115. So subtract the 115 from both sides. And I get, is that 72 equals 8n divided by 8. n equals 9. So in the 9th season. So the 9th season would be it. C, is it reasonable for the pattern to continue indefinitely? Remember what I said earlier? I mean, I've said in previous lessons. Indefinitely, generally, the answer is going to be no. Same thing here. A perfect game of bowling is 300. You can't get any better on that. So if you keep on going on and on, you're going to eventually pass 300. So it's not possible. No. A perfect game or a max game is 300. The sequence will go past that. So no, it's not possible. Now let's do for you to find the sum. So they want me to find the sum of each arithmetic sequence. So on this one, they tell me the first term is negative 16, the common difference is 6, and then I want to find the 24 terms. Now, a lot of people like to use this formula. There's one catch here, though, right? N is 24, that's good. U1, negative 16, perfect. UN, a lot of people put 24 again. It's not. That's a term number. You have to figure out what UN is to figure out to use this equation. Sometimes you have it, sometimes you don't. Now, you can find it pretty easily. You use the formula. I know that I'm looking for the 24th term. My common difference is 6. My first term is negative 16. So you can find that term very easily, but you need that term to use this formula. A lot of times I would use this formula instead, because you need a little bit less stuff. All you need is the first term, the term number, and the common difference, which is what we have. So if I want the sum of the first, let's write the formula down first. If I want the sum of the first 24 terms, that makes this 24, which makes this 24. U1 is negative 16. 16. N is 24 again, and my D is 6. So S of 24 equals 12 times negative 32 plus 23 times 6. Like that. Now, a lot of people, the only problem here is people get sloppy. We have to do this part first, parentheses first. So multiply this, add it to 32, and then at the very end, we can multiply by 12. Or you can put in your calculator. These numbers are going to get kind of big eventually. So I go 12, negative 32, plus 23 times 6. Remember, it's prepared to follow order of operations. So 1272. So when I take the sum of the first 24 terms, remember that this means I'm adding like all the terms up together. So first term plus second term plus third term, you get this. Like you see right here. Right, if you add them all up, you get something like this. Next one, the first 100 even natural numbers. So we just gotta know what those are. So the first even natural number is 2, then 4, then 6, blah, 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 until I get to 100 even natural numbers. Now in this case, we do a little shortcut. The first 100 even natural numbers, well, since we're going by 2, it's not gonna be 100, it's actually gonna be 200. It's the last term. If you can figure it out, it makes your life a lot easier, because then you can use the shortcut version. Right there, and we'll do that right now. Right, so I'll use the shortcut version for this time. Okay, so I want to find the sum of the first 100. So this is 100, this is 100. U1 was my first term, what's this 2? If you figured out the last term was 200, because this even number is counted by 2s, then this is just 200. Simplify it, 50 over 50 times 202 should get you 0, 1, that's 10,100. 10,100. That looks ugly. There we go. There it is. If you didn't figure it out, you can use this equation. It's the same. My first term is 1. My common difference is, my first term is 2, sorry. My common difference is 2, and I want 100. So it works the same, you just plug into a different equation. So either way it works. Let's go to this last two, which will be a little bit tougher. So this first one here. I want to find the sum of all this. How can you tell? The little plus signs. So we can use either one. We'll use the shortcut one that people like. Specifically here, I have the last term. So there's my 200. And I have my first term. There's my 4. What I don't have is n. How many terms is this? From 4, 8, 12, how many terms is it? So if you're not sure, remember the trick. If you're missing something, go back to the original equation. Anytime you're missing, go back to the original equation. Plug in things you do know. So what I do know is this. The first term is 4. The common difference, right? What am I adding every single time? 4. 4, 8, 12. So it's 4 also. The last term is 200. So over here, that's what that is. This is 200. What I don't know is n. But I know everything else. I could just solve for it. 200 equals 4 plus n minus 1 times 4. Now you can distribute the 4 and do all that. I'm going to do this. And let's do that actually. That's probably the easiest. So 200 equals 4 plus 4n minus 4. These cancel. 200 equals 4n. Divide by 4. N equals 50. So n equals 50. Sorry, I do that a lot. So now I go back and plug it in. And now I know my n is 50, my first term is 4, and my last term is 200. So I simplify this, I get 25 times 204. I don't know what that is. $500. I feel like I should know that. And I get that. That's the answer. Which is kind of crazy. You add 4 plus 8 plus 12 all the way. You get 500. Anyway, last one. Same idea. Right? Exact same process. I have the first term. I have the last term. But I don't know how many terms I have total. So we're going to do the exact same thing. I know the last term is 72. I know the first term is negative 24. I don't know what n is. So anytime you're missing, you go back to the original equation. So you go back to here. And plug in what you do know. Right, so we know the last term is 72. That means this guy right here is 72. The first term is negative 24. What is our common difference? It looks like we're adding 6 each time. We're getting smaller and smaller. Or bigger and bigger, actually. It looks a little weird, but you're adding 6 each time. So 6. So I have this. Simplify. I can add these up. 72 equals negative 30 plus 6n plus 30 plus 30. 102 equals 6n divided by 6. 102 divided by 6, that's 1, that's 42. So 7. N equals 17. So 17 goes here. So and that with my calculator, right? So type that in. I got 17 over 2 times negative 24 plus 72. And that's going to get me 408. And that's the sum of all these put together. So instead of adding them all one by one, just simplify and put in your calculator, and we are done.